Hi, my name is Yusuf Eustace, and today I'm going to be teaching you expansivity. Under expansivity, we have three types of expansivity, which are linear expansivity, area expansivity, and cubic expansivity, which can also be called volume expansivity. Linear expansivity, this is the increase in length per unit length for each degree rise in temperature. Area expansivity, this is the increase in area per unit area for each degree rise in temperature. And cubic expansivity, which is volume expansivity, is the increase in volume per unit volume for each degree rise in temperature. Let's start deriving their formulas. For linear expansivity, I told you that this is the sign for it. Therefore, linear expansivity is equal to increase in length, which is L2 minus L1 per unit length, L1, that's over L1 for each degree rise in temperature. Titan 2 minus Titan 1. Let's derive this formula. This is meters all over this meters times all this Kelvin. This is meters at the bottom and meters at the top. We cancel and cancel, which is equal to 1 over Kelvin, which is equal to per Kelvin. That is the unit for linear expansivity. Let's go to area expansivity. Which is the increase in area. This is what we denote it with. Area expansivity is the increase in area. A2 minus A1 per unit area per A1 for each degree rise in temperature. Titan 2 minus Titan 1. Let's derive this. That's going to be meters square all this all over meters square times Kelvin. Cancel, which is equal to 1 over Kelvin, which is equal to per Kelvin. See that? Let's go to cubic expansivity. This is what we denote it with. It can also be called volume expansivity, I already told you. Then, cubic expansivity is the increase in volume V2 minus V1 per unit volume V1 for each degree rise in temperature, Titan 2 minus Titan 1. Let's derive this. Let's derive the unit for cubic expansivity. This is going to be centimeters cube. Centimeters. See that? Let's go to cubic expansivity. This is what we denote it with. It can also be called volume expansivity, I already told you. Then, cubic expansivity is the increase in volume V2 minus V1 per unit volume V1 for each degree rise in temperature, Titan 2 minus Titan 1. Let's derive this. Let's derive the unit for cubic expansivity. This is going to be centimeters cube. Centimeters cube all over. You can also use meters cube if you like. Centimeters cube times Kelvin. Cancel, which is equal to 1 over Kelvin, which is equal to per Kelvin. Now, what do you see here? All their units are all the same. Per Kelvin. Let me relate linear area and cubic expansivity. One area expansivity is equal to 2 linear expansivity. This is a very important note. And 1 cubic expansivity is equal to 3. Alright, our first example is, if a metal rod of length 50 meters expands when heated at a temperature change of 10 Kelvin, find the change in length. Open bracket, linear expansivity of metals, which is the sign. is equal to 1.5 times 10 raised to the power of minus 8 per Kelvin. Close that bracket. First step in all this, we are going to have to bring out stops. First thing we bring out, they say a metal rod of length 50 meters, that's L1. L1 is equal to 50 meters. Expands when heated at a temperature change of 10 Kelvin. I already told you temperature change is the same thing as increase in temperature, which is Titan 2 minus Titan 1. Titan 2 minus Titan 1 is equal to 10 Kelvin. They already helped us convert. Find the change in length, change in length. That's L2 minus L1 is equal to question mark. Linear expansivity. 1.5 times, 10 raised to the power of minus 8 per Kelvin. The formula for this is linear expansivity is equal to L2 minus L1 all over L1 times Titan 2 minus Titan 1. They have given us this. We are looking for this. Therefore, 1.5 times 10 raised to the power of minus 8 is equal to x all over L1 is what? 50 times Titan 2 minus Titan 1, 10. Therefore, 1.5 times 10 raised to the power of minus 8 is equal to x all over 5 times 10, 500. Since we have gotten everything, we have to balance and cross multiply. Therefore, 1 times x is equal to 1.5 times 10 raised to the power of minus 8 times 500. Therefore, x is equal to 7.5 times 10 raised to the power of minus 6 meters. That's what we are looking for. And we got it. So this is the answer. Example 2. Let's start bringing out stops. A wire is 20 meters long. Because they said linear expansivity, that's going to be L1, 20 meters. Is heated from a temperature of 5 degrees Celsius. Titan 1, 5 degrees Celsius. So 55 degrees Celsius. Titan 2, 55 degrees Celsius. If the change in length is 0.020 meters, change in length is L2 minus L1 equal to 0.020 meters. Calculate the linear expansivity of the wire. We are looking for linear expansivity. Let's bring out the formula, which says linear expansivity is equal to L2 minus L1 all over L1 times Titan 2 minus Titan 1. Therefore, linear expansivity is equal to L2 minus L1 is what? 0.020 all over L1, 20 times Titan 2 minus Titan 1, which is 55 minus 5. 55 minus 5. Therefore, linear expansivity is equal to 0.020 all over 20 times 55 minus 5, 50. Therefore, linear expansivity is equal to 0.020 all over 20 times 50, 1000, which is equal to 0.000020. In standard form, this is represented as 2 times 10 raised to the power of minus 5 per Kelvin. Remember, unit is the most important thing in life. I hope you understood everything that I just placed on the board. Please like, comment, and share. And don't forget to subscribe to our YouTube channel so you can be updated in case any other video like this comes up. Thank you.